If industry rumors are to be believed, electric vehicles may soon face an existential challenge. Toyota, a brand synonymous with sustainability, is reportedly on the verge of introducing an engine that could revolutionize the entire automotive industry. Instead of relying on electric batteries or hydrogen fuel cells, Toyota is said to be developing a water-powered engine that promises to be uniquely environmentally friendly. While it may sound like something out of a science fiction novel, Toyota is no stranger to pushing the boundaries of technology. The company already has a strong presence in eco-friendly automotive technology with hydrogen-powered vehicles like the Toyota Mirai and its new 1.6-liter hydrogen 3-cylinder engine. However, this new engine seems set to be something entirely different. The concept of a water-powered engine is not new, but it has often been relegated to fad projects, academic studies, or low-budget garage experiments. So far, no major automaker has managed to produce a water-powered engine that is practical, reliable, and ready for mass production. However, with significant R&D budgets and world-class engineering talent, Toyota is well-positioned to turn this seemingly fantastic idea into an everyday reality. So how does Toyota's water-powered engine work? It surpasses existing fuel technologies by performing electrolysis in real time, creating a self-sustaining cycle. Unlike conventional hydrogen vehicles that require bulky high-pressure storage tanks, this engine uses a water tank equipped with electrodes. When these electrodes receive a higher voltage, they immediately split water into its basic elements, hydrogen and oxygen. This instant electrolysis eliminates the need for external hydrogen storage, resulting in a more compact and lightweight design. Once the hydrogen is isolated, it is directed to the combustion chamber, where it is ignited in a process similar to that of compressed natural gas. The entire setup is a stand-alone feat of engineering efficiency, removing the need for complex refueling stations or external storage systems. At the same time, the environmental impact of this technology could be transformative. The new engine emits almost zero emissions, making it a formidable competitor to even the most advanced electric vehicles. Moreover, it avoids the environmental repercussions associated with the extraction of rare earth metals for batteries and the petroleum consumption linked to conventional engine. In fact, beyond its ecological virtues, the engine is highly user-friendly. A vehicle equipped with this engine can be refueled using distilled water, which is both abundant and accessible. This stands in stark contrast to the logistical challenges of charging electric vehicles or refueling hydrogen vehicles in regions where infrastructure is still developing. In this regard, the environmental potential of the new engine is extremely promising. It produces almost zero emissions, rivaling electric vehicles, while offering greater convenience. With easy refueling from virtually any diluted water source, this engine eliminates the logistical hurdles that plague both electric and hydrogen-based vehicles. Moreover, the engine reduces the environmental degradation associated with oil extraction and the mining of rare earth metals, processes that heavily pollute and endanger local water supplies and soil quality. As a result, compared to both hydrogen combustion engines and internal combustion engines, Toyota's water-powered engine stands out as an environmentally friendly marvel. Storing water is simple and inexpensive, unlike hydrogen, which requires heavily armored and meticulously monitored tanks, along with significant financial investment. Hydrogen is difficult to maintain in its pure form, as it tends to escape through even the smallest irregularities in the tank, requiring constant monitoring and maintenance. In contrast, a water-powered vehicle can use a standard plastic container as a fuel tank. Storing hydrogen outside of a vehicle also presents challenges, requiring specific temperature conditions and sealed, robust tanks. In comparison, pure water is readily available in most supermarkets and can even be produced at home using basic chemistry. The high cost of producing and storing hydrogen has hindered its widespread adoption, driving up consumer prices and undermining its viability as a long-term fuel alternative. Water-powered engines may seem like a futuristic concept, but they are poised to be extremely practical for everyday use. Contrary to some perceptions, these engines are not lacking in power. They have performance equivalent to conventional gasoline engines and could potentially even exceed them. Water-powered engines are capable of producing up to 3 times more energy in megajoules compared to their gasoline counterparts. The absence of permanently stored, highly flammable fuels significantly reduces the risk of fire or explosion. With their simple mechanical design, water-powered engines offer an economical and scalable alternative to conventional gasoline engines. Their simplicity makes them more cost-effective than electric vehicles or fuel cell electric vehicles, which could make them an ideal solution for developing countries with limited oil resources. For example, an Iranian scientist successfully converted his Peugeot 405 to run on water, demonstrating the feasibility and potential of this technology even without vast resources. Water-powered engines also have impressive fuel efficiency. The Iranian scientists' converted Peugeot 405 achieved 30 to 40 miles per gallon of water, significantly better than the gasoline engine of the same model. This shows that, with proper engineering, water-powered vehicles can deliver outstanding fuel economy, making them even more cost-effective to operate. Still in its infancy, water-powered engines look promising, don't they? But the road to widespread adoption is not without challenges. Safety concerns, for instance, have been a barrier for similar hydrogen-powered vehicles. However, the armored designs of hydrogen combustion engines suggest that safe water-powered vehicles are within reach. A stable storage of hydrogen in water further reduces these risks. Reliability is another advantage. The simplicity of the engine makes it less prone to failures compared to electric vehicles. In case of an issue with the electrolysis process, a spare hydrogen tank could potentially be carried, although this is not a feature of Toyota's current design. Additionally, maintenance costs are expected to be low due to the engine's uncomplicated design, with fewer mechanical components and electronics that could fail. What do you think about Toyota's new water-powered engine? Would you like to drive a water-powered car? Don't forget to share your thoughts and opinions in the comments section.